Welcome back. I hope you would do well in the state of New York. Please take a moment to check your answers, see how you did. If you did well, have no questions, then please move on to the next set of exercises, which take it up a notch. And if you do have questions, please stick around and we'll work them out. So I'm going to lift the paper now and move on to the robot sheet. So the poor little robot's not plugged in at first, but he figures it out soon. For number 1, as long as you know that the 1/2 power means the square root, this is just asking for the square root of 81. And I know you know that is 9. For number 2, there are 2 perfectly good ways to solve this problem. Now you have to realize that the denominator is going to be the root. So we could think of this either as the cube root of 64 squared, or we could think of it as the cube root of 64 squared. These are both going to come out to the same thing, whether we square the 64 first and then take the cube root, or if we take the cube root of 64 first and then square that answer. Either way, it is the same result. Personally, I don't want to have to square the 64 and then take the cube root. I mean, I know how to do it. I just got to go with the easy route. The cube root of 64. Something times itself, and then that answer again times that number comes out to 64. And that's a nice, easy number. The cube root of 64 is 4. And when we square that, we are going to get 16. Number 3, it's once again the 2/3 power. And they want us to evaluate it at x equals 8. So we can either change this and then put the 8 in, or we can put the 8 in right away. So this, I'm going to put the 8 in right away. So it's going to be 8 to the 2/3 power. As in the previous problem, we could write this the cube root of 8 squared, means square the 8, find the cube root, or we could write it as the cube root of 8, find the cube root, and then square it. It doesn't matter which operation we do first. Well, 8 squared is 64. And we found out up in the previous problem that the cube root of 64 is 4. Or we could do the cube root of 8, do the part in this parentheses first, which is 2, and then square it. It still comes out to 4. Either one of those will be fine. For number 4, they want us to evaluate this expression when a is 16. So we're going to have 16 plus 16 to the 1/2 minus 16 to the 1/4 power. Well, 16 is 16. The 1/2 power means square root. So we're going to have plus the square root of 16 minus the 1/4 power means the 4th root. So 16, square root of 16, I'm sure you know, is 4. And the 4th root of 16, there is a nice number that when you multiply the 4 factors of this number, you end up with 16. And it's got to be pretty small. And of course it is 2. So we end up with 20 subtract 2, which is 18. Okay. This one, I'm afraid I did differently. We could put this 2 in here, 2 to the 1/2, 2 to the 3/2, or we could simplify this expression first and then plug the 2 in. It doesn't matter. I'm going to look at this first and realize that this simplifies. We have the same base, and we're multiplying, so we can add these exponents. That this is going to be c to the 1/2 plus 3/2, which will be c to the 4/2, and that's the same as c to the 2nd. That this expression here, just using one of the rules of exponents, if we have the same base, we can multiply by adding the exponents. And that would imply 2 squared equals 4. Moving further, next page. Oh my. So they want us to put in a 27. We can do that. So we would have -1 over 27 raised to the 2/3 power. Okay, that means we can either take the cube root of -1 over 27 squared, or we can take the cube root of -1 over 27, and when we're done, square it. Personally, I do not want to square 27 in my head. These problems were supposed to be done without a calculator. So I'm going to go for this one. We can take the cube root of this. We could further make it, if that'll make it easier for you to see, the cube root of -1 over the cube root of 27, and that whole answer is going to be raised to the 2nd power. Well, the cube root of -1 is -1. And the cube root of 27, we did this when we were factoring perfect cubes, is 3. And that's being raised, all of it, to the 2nd power. When you multiply this fraction times itself, you get a positive 1/9. So number 7, they gave us x to the -1/2 plus x to the 0. We can simplify this a little bit first and then plug in the 25, or we can plug the 25 in right away. It doesn't matter, whatever you like. I'm going to make this 1 over x to the positive 1/2. Now I can't add the exponents because we aren't multiplying these. And we're not dividing them. That's a plus sign there. They're going to be separate terms. And now I'm going to plug in the 25. Well, the 25 to the 0 is easy. That's going to be a +1. And 1 over 25 to the 1/2, as long as you know that that 1/2 means the square root, this problem just got a lot easier. Because we can nicely take the square root of 25. That's going to be 1 over 5 plus 1. We could call that 1 1/5. If you like it better as 1 and 0.2 or 6/5, that's fine. I just left it as 1 and 1/5. Oh my, now we got lots of lovely things happening. I don't know what you'd like to do first. I know one thing we can't do. We cannot just multiply -3/2 times this and -3/2 times that. If this was a multiplication sign, we could get away with it. Or if this was a division sign, we could get away with it. But adding or subtracting, we cannot just take the powers of this entire parentheses. We can't distribute the powers that way. Okay. So substituting, I'm kind of tight for room here. Last time I messed with the x's first before sticking the number in. This time I'm just going to arbitrarily stick the number in. We got 1/3 to the -1 plus 1/3 to the 0, and that's all raised to the -3/2. Okay, as you worked on the problems with Mrs. Milburn, this -1 power just means the reciprocal. So this is 3 over 1, or just 3 to the first, plus anything to the 0 power is 1. Except 0 to the 0 power, of course. And that's all being raised to the -3/2. Well, this is pretty nice now. 3 plus 1 is 4. 4 is being raised to the -3/2 power. Your choice, you can go right as a reciprocal immediately. You can make this 4 to the -3rd and then take the square root of it. You can take the square root of it and then raise it to the -3rd. There are all kinds of options here. I'm going to write this as the reciprocal, and I'm going to have to put it over here somewhere. This is going to be 1 over 4 to the +3/2. Okay, so what does that mean? 4 to the +3/2? We can either write it as the square root of 4 to the 3rd, which would be 1 over the square root of 64, which would be 1/8. Or, if we don't like that, we could write it as 1 over the square root of 4, that answer being raised to the 3rd power, which would be 1 over 2 to the 3rd, which still comes out 1/8. Finally, they want us to plug in a 9. So we have 3 times 9 to the -1/2 power. Now that doesn't mean we take 3 times 9 and make 27 and then raise that to the negative 1/2. Only the 9 is getting raised to the negative 1/2. So we could rethink this as 3 times 1 over 9 to the 1/2 power. That's not the only way we can do this. But the 3 has nothing to do with this exponent here. It's just multiplying whatever this answer is going to be. Well, that would equal 3 times 1 over, if you know that 1/2 means the square root, so that would be 3 times 1 over the square root of 9 is 3, and we would end up with just 1. So welcome to the world of state testing in New York, and we'll move on to something